Okay, so we're going to be getting into a different type of bonding here, but really quick, I want to go back and review a basic concept of ionic bonding. All right, so what caused ionic bonding was the octet rule. All right, so if you had two neutral atoms, all right, fluorine would have this electron configuration, lithium would have this electron configuration, and both of these guys want to have the electron configuration of the closest noble gas, right? So fluorine wants to have neon's configuration, lithium will want to have helium's electron configuration, and because of that, lithium would be inclined to lose an electron, fluorine would be inclined to gain an electron, and in doing that, that would create a negatively charged fluorine and a positively charged lithium. All right, notice that the electron configuration of this guy is helium's configuration. This configuration is neon's, so they're both happy. All right, so because this guy picks up an electron, he is negative. This guy loses an electron, he is positive. Therefore, they have a reason to want to stick to each other because a positively charged atom is going to be attracted to a negatively charged atom. All right, that is what an ionic bond is. It's the attraction of two oppositely charged atoms. All right, so before moving on to covalent bonding, I want to go over. I want to give another way of thinking about the octet rule. All right. So another way of thinking about the octet rule is just that atoms like to possess the same number of valence electrons as the closest noble gas. All right. So if you take a look at this right here, does this guy have the same number of valence electrons as neon? All right. Yeah. All right. This is the electron configuration of neon. Same thing with this guy right here. So the thing is that ionic bonding allows this to happen, but it's not the only way. All right. So to show this, take a look at this picture right here. All right. The octet rule can also be achieved by atoms sharing electrons. So what do I mean by this? All right. So those guys right now, these are two fluorine atoms. They currently have 7 valence electrons. All right. But what do they want? All right. According to the octet rule, they both want 8 valence electrons, okay? So in covalent bonding, instead of one atom stealing an electron from the other, what's going to happen is they're going to share them, all right? So if you can picture these guys coming together and sharing these electrons here, this is essentially what you would have, right? So take a look at the circle right here, right? How many electrons would this fluorine possess, right? He would have 8 valence electrons. That's how many electrons neon has. Right? So he is obeying the octet rule because he now possesses the same number of electrons as neon. Right? So this guy right here also possesses 8. Right? So the electrons that are being shared can be considered to be owned by each of the atoms. All right? So that's what a covalent bond is. A covalent bond is just the glue that holds two atoms together, which is caused by the sharing of electrons. Okay, so I've used this term sharing, all right, and you might look at this picture and think that sharing means that you physically have two electrons that are located in between the two atoms. Right? That's not entirely true. So I'm going to show a little video that gives a little bit of a better picture of what this really looks like.